Chapter 9, Section 12, Practical Applications, Completeness and Hilbert Spaces. In this section, we will see how the concept of completeness and structure of Hilbert spaces play an important role in data science. We will explore why certain mathematical spaces ensure convergence, and how this underpins models like support vector machines, enabling stable learning in high-dimensional environments. Let's start by briefly refreshing two key concepts, completeness and Hilbert spaces. Completeness means that whenever you have a sequence of points that are getting closer and closer together, what we call a Cauchy sequence, there's actually a point inside the space where they converge. In other words, no matter how small the gaps become, the destination is guaranteed to exist inside your space. Not outside, not missing. A Hilbert space is simply an inner product space that is also complete. For an inner product space, we can measure distances and angles. If it is complete, we never lose our limit points. It is a perfect environment for doing geometry, optimization, and projection, even in very high-dimensional or infinite-dimensional spaces. So, why should we care about the completeness when building machine learning models? Here is the core reason. In machine learning, we rarely find exact solution in one shot. Instead, most learning algorithms approach the solution gradually, step by step, getting closer and closer. Each step creates a sequence of approximations, a sequence of guesses that improve over time. In order for this sequence to actually reach a solution, the space we are working in must be complete. If it is not complete, even though our steps get closer and closer, there might be no actual solution inside the space. We should endlessly chase something that does not exist. As an example of practical application, let's see how Hilbert space relates to support vector machine, SVM for short. Support vector machine is a type of machine learning model used for classification tasks. Given some data points belonging to two different classes, SVM finds the best way to separate them with a straight line, or a flat surface called the hyperplane. Not just any separating line. It tries to find the best line that maximizes the margin, the distance between the line and the nearest data points from each class. A larger margin makes the model more robust. It reduces the chance of making mistakes on new unseen data. It helps the model generalize better. So, support vector machines are about finding the widest possible safe gap between classes. So, how does Hilbert space fit into this picture? Think about this. To find the best separating hyperplane, we need to measure distances to define the margin, and measure angles to define the orientation of the hyperplane. And we need to do this even in very high-dimensional spaces. All these operations, measuring distance, angles, and projection, require an inner product structure. But more importantly, support vector machines often transforms the data into a very high-dimensional or even infinite-dimensional feature space to make it easier to separate. In that case, it becomes absolutely essential that the space is complete. Otherwise, the optimization process might not converge, and the model would not be stable. That is why support vector machine operates inside Hilbert spaces, a complete inner product space where Even infinite-dimensional calculations remain stable and well-defined. Let's wrap up. Without Hilbert spaces, many of the techniques we use in modern data science, such as classification, dimensionality reduction, and high-dimensional learning, would not be mathematically stable or even possible. Completeness is not just a technical detail. It is what guarantees that the methods we build will work. That is, they will converge, stabilize, and produce meaningful results. In short, normal spaces give us distance. Inner product spaces give us angles and projections. Hilbert spaces give us the guarantee that our whole process is safe, stable, and trustworthy. Thank you for watching. Please thumbs up and subscribe to my channel.